Alright, so this video we're going to review parametrics. In the last video we reviewed vectors. So there is a little bit of tie-in with vectors and parametric equations, but we're really just looking at the projectile motion model with parametric equations. And this is always the x and the y that you're going to be given for the formulas. You're going to be given some key information, so notice this is if your time starts at 0. Okay, so if there is any adjustment in the time where you start, then you do need to make that adjustment in the equation, and I'm going to show you how to do that. So in this problem, here's an example. You're throwing a baseball with a friend at t equals 7. You throw a ball at an angle of 5.2 with a horizontal speed at 98.3 feet per second. And again, that always does have to be in feet per second. Okay? She releases the ball 2.7 feet above the ground, and you're looking at the parametric equation. So notice that you are going to take this 7, and that's going to go into t minus 7, because you're starting 7 seconds after the time of 0. Okay? 98.3 is your speed, your initial speed, and then your angle is at 5.2, so that's your x equation. And then again, same thing for the y equation. I'm going to take t minus 7 squared and t minus 7 here. That's going to be that 7. And then negative 16 is always going to stay the same with the equation. 98.3 is the feet per second, my initial velocity, and 5.2 is the angle. 2.7 is where I release the ball. So here are my two equations. If it were at time equals 0, let's say it was t equals 0, notice that with both of those t's, or with all of those t's, it's just t instead of t minus 7. Okay, so that's the only slight difference that you may notice from when we did these in class. So let's take a look here. It says Alfreda and Kanisha are performing a physics experiment in which they will launch a model rocket. They launch it at t equals 9 seconds at a 78-degree angle, with the initial velocity of 158 feet per second, and it's on the ground. So what this does is this gives me a couple of things. First of all, I know for this, I'm going to be doing a t minus 9, because I'm starting 9 seconds after 0. I know this is my initial angle. I know that this is my initial height, so it's h sub 0, and I know this is my initial velocity of v sub 0. So now I just take those and I plug it into that basic parametric equation model, which is up here. V sub 0 cosine of theta t, negative 16t squared plus v sub 0 sine theta t plus h sub 0. So again, my x is going to be my initial velocity of 158. Then I'm going to take cosine of the angle, which is 78 degrees, and then t, minus 9. Okay? Then for my y, I'm going to take the negative 16. Then I'm going to take the, going back here, t squared. So in this case, instead of t, I'm starting 9 seconds after, so I'm going to use t minus 9 squared, plus my initial velocity, 158. Here it is right there, my initial velocity, sine of theta. So sine of 78. Then again, t minus 9, where my t goes. And then it's at the ground, so it's just plus 0. So now it says the rocket is supposed to release a parachute at 200 feet in the air. How long after the launch will the rocket release the parachute? So for these, we've encouraged you to use your calculators. But in this case, I'm looking for when my vertical distance is 200. So remember, y is your vertical distance. Okay? So when I put these in my calculator, I'm going to take, and I have to make sure my mode is in parametric. So I'm going to go down here and put it in parametric mode. Okay? And then I'm going to go to y equals, and notice it gives me an x1 and a y1. So I'm going to plug all of that in for my equations exactly how it looks. So there's my t equation, and then I'm going to go down here and plug in my x equation. Now I'm going to plug in my y equation, It's very long. Make sure I'm getting everything in here. You don't really need the plus here, but I'm going to go put it in. Now, if I look at my table of values, I'm really looking for when my y value is 200. So if you notice for all of these, remember I didn't release it until 9 seconds. So I'm going to get a lot of negative values at the very beginning. But if I scroll up here to 9, notice I have my 0, 0 up here at 9. And I'm looking for when it's 200. Well, if you notice, that's somewhere between 10 and 11 seconds. My y value will hit 200. So you can either estimate or you can change your table set. And you can look a little bit closer between 10 and 11 and get a more exact value. To do that, you're going to hit second window. And then you're going to have your table start at 10 because it's somewhere between 10 and 11. And you want it to count by tenths, so you're going to say 0.1. If you go back to your table, you'll notice now it goes 10, 10.1. And you can really narrow it down to about 10.5 or 10.6. So it's at about 10.5 seconds. If the rocket does not release the parachute properly, how far away from the launch site will the rocket crash? So this is basically when will it hit the ground again. So this is when, again, when is my y going to equal 0 again? Remember, this is when is my y going to equal 200. Okay? So assuming that my parachute doesn't launch, I'm going to go down here. I'm going to change my table set again, and I'm going to have it just count by, maybe let's do halves this time, so I can look through my table. And you'll see that my y gets really big, and it's coming back down now. We're up to 19 seconds. Oh, notice that at 19 seconds we hit negative values. So that means it's actually hit the ground somewhere between 18 and a half and 19 seconds. So if I change my table set again, I'm going to go to 18 and a half, and I'm going to have it count by tenths again, so I can see a little bit more exact where it hits the ground. So if you see here, it goes at 18.6, 18.7, somewhere in there. So I'm going to say at about 18.6 seconds. And that's all you're going to do for those problems. All right. So that's parametrics. There are going to be some problems on matrices as well, but that will be mainly doing some determinants and inverses, which we have talked about a lot. A matrix does not have an inverse when the determinant equals 0. Okay? So 2 by 2 matrices, remember you cross multiply. Basically you cross them, and so it's going to be A times D minus B times C. So in this case it's going to be 18 minus negative 2, which will give me 20. So that's how you do these. The answers for those are also a little bit later, so you can see what your answers are for those. I believe they are here, but I could be wrong. Let me see here. Nope, those would be those. Those would be them. So again, here's your practice, your answers for those. Okay. 3 by 3 determinants, you're going to, there's a couple of different ways you can do them. The easiest way is just to plug them in your calculator, so I can show you how to do one of those. So you want to go to your matrix menu by hitting second x to the negative 1. You're going to edit matrix A, make it a 3 by 3, and put in the matrix. Okay, and then you're going to go back to your matrix menu and go to Math, and DET means determinant. Oops, I don't want to do that. Go to your home menu first. Then go to Matrix, then go to Math, and you want determinant, select your matrix A, and you get negative 24. Okay? Alright, if you have any questions, you are welcome to ask. But seniors are going to follow the senior schedule if you have an exam, and everybody else, you will have your RQA in June.